All right, hey everybody. So now we're going to start the bulk of statistics. This chapter is about central tendency and how to kind of analyze the data. Um, so we're just going to jump into it. Okay. I'm going to, there's a link where you can download like this black PowerPoint and you can print it off if you want to and like work out the problems with me as I do them. I suggest that that's the best way to learn this material, just like you would be taking notes in a real classroom, but you know your learning style. All right, so, excuse me. So in statistics, you have your population, which is like everybody. So if I wanted to study, I don't know, average number of TVs in the American home, I just looked at my TV, right? Okay, and then I would need to ask literally every single American. That's like a billions of people. It's impossible. And so we do a little sample. Maybe we ask 5,000 people. Okay, that's still a lot, and so there's ways to do that. Um, or maybe you're conducting a sample, and so you ask 50 friends or something. And then you can find like the median, mean, mode, standard deviation, IQR. You can find all these statistics, okay, about your sample. So a statistic here, a statistic is a parameter, same concept, except a statistic applies to the sample, and then we're going to take that information and infer it about the population. And so maybe we know the average American home has 2.4 TVs. I don't know. I made it up. Okay. And so we want to check and see if that's right. So 2.4 TVs. I don't know how. I'm just made that up. Okay. And so we want to check to see if that's right or accurate, or maybe that was done in like 2002 and we want a more accurate statistic, and so we're going to do it again. And so maybe we ask 50 people, and we find that the average, the mean, okay, is in 2017 is, I don't know, 3.2. Again, I'm making this up because I'm just trying to illustrate a point. And so then we would take that number, that average 3.2, and apply it to the parameter. I mean, we would apply it to the population because it's literally impossible to ask every single American, which is why the U.S. Census is only done every 10 years because it takes a very long time to do it. And even then, they still don't get everybody, but they get the bulk of people. All right, so statistic and parameter, they're both characteristics. One applies to sample, statistic sample. One applies to population, parameter, population. All right, here's the deal in statistics. A couple of things that I find personally really hard about stats, like as a class, not like a statistic that we were just talking about. You have these crazy symbols, you have crazy formulas, and you have these odd definitions, and you're like, I don't understand it all. Just know that I'm going to break it all down for you, and I don't get wrapped up in this guy right. Okay, that is the formula for mean, but you know what the mean is. The mean, you take them all up, you like add all the people up, all the terms, and divide by however many there are. That's what mean is. If you wanted the official math definition, there it is. So it depends if we're talking about the sample. Okay, if we're talking about the sample, then it's x bar. So it's x, the literal bar over it. Okay, if we're talking about the population, it's called mu, like a drunk cow. Okay, you should laugh because it's a funny joke. Maybe just to me. And that's really all that matters in these videos because I'm recording them and nobody else is here. Okay. And so you're going to see those symbols all the time. X bar and mu. That means mean. That is what we typically consider average. You add them all up, you divide by however many there are. So if you see crazy formulas, which you're going to see in the book or you're going to see in my notes, I'm going to break them down for you. But I also need you to know that those formulas exist and you don't need to be intimidated by those formulas. I'm here to help. Whoa. Okay. So there's different kinds of averages. There's the mean, which is your average. You add them up, divide by however many there are. Okay, so mean is what we consider average. There's the mode, which is the most often. You can have bimodal, 2 values that occur the most often, multimodal, which is 3 or more values that occur the most often. You can have no mode. Okay, no mode means a mode does not exist. It is not the same as having 0. 0 is a number, and if, you know, we asked how many people have a 3D TV in their house, and we asked 50 people, and you know, we said, how many TVs do you have in your house that are 3D? Like, I don't know, they're coming out, they're like these curved TV things. I don't know. And the number that appeared the most often was we have 0 3D TVs, then that would be the answer. So 0 is a number, and so if you have all the numbers that appear the exact same 2 times, they all appear once, or they all appear twice, then you have no mode. It's not the same as 0. You have modal class. I'll explain that more later as we do an example. It'll be really kind of evident. Okay, you have median. Okay, to find the median, the middle, the median of the road. Louisiana, we call the median the road the neutral ground. I don't know if you're familiar with that. Sometimes in Mississippi or Alabama they do the same. All right, and so to do the median, your numbers have to be least to greatest. They have to be. Otherwise, you can't really find the middle. If you've got 2 numbers in the middle, you find the average. You add those 2 up, and you divide by however many there are. I'm just kind of quickly going over these. You should know how to find mean, median, and mode. All right, then there's what's called the mid-range. It's just kind of an estimate of the middle. So you do the high plus low divided by 2. Right, and then the color for highlighting. All right, for rounding, you always go 1 smaller. So if everything like is in whole numbers in the word problem, you need to round to the tenths. As everything in the problem is to the tenths, you need to go to the hundredths. So everything is 1 decimal place smaller, so you can get a pretty good accuracy. All right, so I went over those really fast, but they are really the basics of statistics and central tendency. And so I'm going to go a little bit more. All right. There are 3 ways to say average. Mean, median, mode. Okay. And the reason we have so many ways is because it depends on the type of data. One type of data, the mean might be the best way to illustrate it. One type of data, the mode might be the best way. One type of data, the best way to say average might be median. So it depends on the type of data. Oh, it's not what I wanted. Sorry. We'll stick to my writing, but I write so big. All right, so 3 ways to say average because it depends on the type of data. And then let's talk about, all right, So in the previous chapter, you learned about different kinds of data. There's nominal, interval. Why did I can't say it all of a sudden? All right, there's ordinal and interval ratio. So interval ratio, that's things with numbers. Okay. Ordinal is a category. Okay, but there's an order. That is a D. That's a D. All right, that's horrible. Order. All right, and then nominal. 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 Why? I don't know. It's like I forgot how to talk all of a sudden, guys. Jesus. All right. I mean, you're only 11 minutes into a video. Just imagine what it's like with a class with me. All right. And then the other one, there's no order. All right. So an example might be, okay, order might be like first place, second place, third place, or good, better, best. Okay. Interval ratio is literally anything with numbers. The temperature outside. How many TVs do you have in your home? Your ACT score, your SAT score, your age, anything with a number. Nominal. Still doesn't sound right. Okay, there's no order. So it'd be like religious affiliation or your race. One race is not better than the other, so there's no order. Categories might be like, what's your favorite color? Something without order. So one color is not better than the other. All right, and then there's depending on the type of data that it is, depends on the best way to display the data and then the best type of average. All right, so when you have interval ratio data, which is the bulk of the data that we're going to look at, you can do a bar graph, you can do a circle graph, you can do a line graph, you can do any of the graphs, okay? But for ordinal and nominal data, like if you were just listing your favorite color, a bar graph would be best. Or like a histogram. They're super close to the same thing. So I'm going to pretty much use them interchangeably. They're not the same thing, but for an intro to stats, close. All right. And this is also category. So these two kind of, they both can have a bar graph. You could figure out the percentages for each kind in the category and do a circle graph. They're both really good. Interval ratio would be maybe like a line graph or a box and whisker plot, which we'll learn about, or a stem and leaf plot. All right, and then the most effective type of average. So for interval ratio, it's mean. It's literally the average. Add them up and divide by how many there are. And then for ordinal, you're looking at categories, like how many happened in each category. And so it's really mode. And then nominal, same thing, mode. You want to know, which thing was the most popular. It's really impossible to find the mean, the average color, like, because that's not a number. And it's, you could find the median, you could argue that, but the best, most effective type of average is mode for the category kind, and then mean. You could also argue median for the interval ratio. So in the next video, so I just kind of laid the groundwork here. In the next video, I'm going to go through like how to actually calculate all this. All right, so I'll see you on the second.